All right. Well, thanks everyone for joining, and people may still trickle in. But today, or for this month, our GDG will have a presentation and discussion on the challenges of building Kotlin multi-platform libraries. And we have with us a Google developer expert in Kotlin and Android, Mohit. And I'll turn it over to you to further introduce yourself and the topic.
Thank you. So yeah, my name is Mohit. I'm a GDE in Kotlin Android, and I've been doing Android for the past 10 years. Uh, Before I begin, I just want to take a poll. You could, message in the chat like how many of you are Android or iOS engineers. You got one Android. Got Android and iOS. So that's great. So that's great. So everyone has, some form of a background. So I'll share my screen to share my presentation. Give me 1 second. Let me see. All right. I want to make sure, could everyone see my screen?
I don't see it yet. I see your video feed.
Oh. Give me 1 second. Let me try it again.
Or I can try setting you as host, if that would help. There, I've set you as host. Let's see if that helps.
Okay, give me a second. Let me try one more time. Oh, could you see my screen now?
Yes, see your Firefox browser.
Oh, how come Keynote is not coming? Let me see. How about now? Do you see my Keynote?
I still see video of you.
Trying to see what could be wrong. Let me leave the event and just come back in.
Okay, yeah, that's fine. So John Mulholland, you said no to Objective-C, I assume?
No, I was saying no, I couldn't see the screen.
Okay.
How's Carl doing? It's been a while, Carl.
Yeah, it's actually been a long time, a couple of years at least.
Yeah, I've been doing watch stuff recently for the last year and a half or so.
Watch stuff?
Yeah, Android Wear.
Oh, okay, cool. That's something I really haven't dived into.
Much smaller screen.
A lot more constraints.
Yep. Are you still at Ancestry, Carl?
I am, yep.
Could you see my screen?
There we go.
All right, thank you. So yeah, my presentation is about how to build multi-platform libraries, and I'll share with you. I won't assume that you know anything about Kotlin multi-platform. I'll share the basics and go from there. And at the end of this presentation, I'll also share with you a demo of actual code of a multi-platform library, an app I built. So in this presentation, I'm going to share with you how do you set up a multi-platform project. And if you were to use it in production, like you're going to have challenge. What challenges would you have if you were to set it up on CI? And when you're building this, what type of API design challenges would you have? So I'm going to share with you all the challenges that I've experienced from my experiences in the past. So, why do you want to build a Kotlin multi-platform library? So in when we do mobile Android development, iOS development, there are common things that we commonly do, right? We communicate with an API that, and we have some form of an API client defined for on Android and on iOS, even like on web. And that's an example of something that could be shared. You could build a common API client that knows how to communicate with some REST API. It could even be for GraphQL, for example. So the other thing, but when we implement like the ability to communicate with an API, we're using different technologies, like maybe LMFire NS URL on iOS, or maybe retrofit on Android. And so the problem is that you're doing double the amount of work to implement that on these platforms. And Kotlin multi-platform, the benefit is that you could all share it in single, a library using Kotlin. So another example is like you may have some form of a caching layer in your app, some abstraction that caches different things. And you could also share that abstraction for both platforms and write it only once. And lastly, the thing that's really important is business logic. Like it might be some logic to calculate something or to determine whether the formatting for the data that you show in the UI, you could share all that business logic in with KMM. So and all of these, all of these platforms, they have different types of architectures, and there are different layers that you could share. For example, the API layer for these different types of architectures. So they all could share some libraries, some shared code, which has all of these different use cases. So let me give you, and that's the benefit of Kotlin multi-platform. Let me share with you how to set up a very simple KMM project. And by KMM, it stands for Kotlin Multi-Platform Mobile. So suppose you want to display a very simple string called like hello Android on Android, and then on iOS, you want to change the string to iOS. So the name of the greeting, the platform name is going to change based on what device you're on. And how do you implement this very simple use case? So this very simple use case will allow you to see how the library is consumed on iOS, etc. So what we're going to do to build this is to build a simple greeter, some class that knows how to give you the right greeting based on which platform you're on, whether you're on Android or you're on iOS. So how do we create a multi-platform app? And when I started to use it in 2018, it was very difficult. There wasn't a lot of IDE support. You had to do things manually. There were challenges in terms of you may see some weird Gradle errors. But now there's a lot of tooling that is now to build a multi-platform project. So in the Kotlin multi-platform world, they're in Android now. They provide you with a plugin, which JetBrains provides a plugin that you could use in IntelliJ or an Android Studio that gives you a template that you could start off of, and it creates all the project structure for you, which is really really nice. That gives you a good starting point. And in the Android ecosystem, there is also basically a library called CampKit by TouchLab, which is another example of a starter kit that you could use and build on top of, and it sets up all the scaffolding for you to build a multi-platform library. So this app is going to build an Android app, is going to build an iOS project basically, and that's what that plugin does. So when you set up your project, you have your shared code at the end. It's going to build a folder for that. Then it's going to build an Android app that consumes it, and it's going to be able to build an Xcode project which also consumes the shared code. So the Android app consumes the code as a jar file, whereas the iOS app would consume the shared artifact as a framework. So we'll talk more about that and what the challenges with that are. So how is a shared library, this library, KMM library, structured inside? Where does the code go? And there is a structure to it or format to it. So when this plugin creates a shared library, it sets up a common main folder. And it also sets up an Android main folder and then a iOS main folder. So common main defines the main API. Basically, it doesn't have logic into how that's implemented in Android and main, and in Android and iOS, that logic goes in these Android and iOS specific folders, source sets. So let's look at how you would implement this greeter class in this shared library. So what it's going to provide, this greeter class, is a platform name. So this is the structure of basically how to set up basically a class. So what's important to know here is that Kotlin Multiplatform, gives you two new keywords like expect and actual. So you can see here it says expect class platform and a val platform, which is some particular string. So this is kind of like an interface like that has to be implemented for both Android and iOS. And expect is, declaring it basically that, making a contract that you have to provide an implementation for both Android and iOS on what platform really means. So that's what expect really means here, expect class platform. And this has a string. It could be anything in here, like functions, for example, depending on your use case. So this is what goes in common, and then what goes into the Android and iOS part. So, for example, in this Android source set, what you would define for platform is something like this. So this here has something called actual class. This is using the actual keyword. So this is the pairing of the expect actual keyword. So anything that is defined in common, you have to define in Android folder. In this source set, you have to define what that implementation is, what it means. So you got to use the word keyword actual class platform. And in here, you would have logic, which is only pertains to Android. And I'll show you an example of that. So this is a very simple example where I'm providing a particular string for Android. So that's what the actual keyword is. And there will be in the IDE gives you really nice icons to indicate that this is implementing a expected, class, common class. So if you don't, specify this, the IDE will give you an error. So how about what happens in iOS? So in iOS, you also want to provide a platform name, and this is the way you would do it. So this is also written in Kotlin. So this whole library you write in Kotlin. And the great thing is that in the iOS source set, you have the ability to, like, for example, like use things from core data. They provides you bindings from that, provides you with bindings on iOS specific things, libraries, foundational libraries. And you could tap into that to define your logic. And actual class platform, you can see I'm using the same pattern basically of using this keyword, and I'm specifying what the platform is, what is the string for that. So this is a very simple example, but it might be something much more complex where you have some external CocoaPod dependency in here, and you are interacting with this library, this external library. In here, you can specify the logic on what's going to happen. So this is an example what's in the iOS source set. So what we have done here is defines a very simple library. We're defining what goes in common, which is the interface, the contract that that the external users, people who are using this library, will utilize basically. So, and then you have what's defined in Android and what's defined in iOS, how that contract is defined. What is the logic that's platform specific. So the next thing you'll have in common is basically you're going to utilize this platform class that we made. You're going to instantiate it. So, and then you're going to get the string, a greeting. So when you look at this class in common, it doesn't have the actual, it doesn't have the expect keyword. So it doesn't have to have the expect keyword. Not all classes do. This is a very simple class. You don't have to provide an implementation for Android and iOS on what this greeter class does. We could just provide that implementation here. This utilizes a common expected class called platform. So there is no, you can't use Dagger like in KMM, like in here. There is a library called Coin for dependency injection, which has Kotlin Multiplatform support. But you could also use the approach of just manually providing your dependencies, for example. So this is a greeter class that the external world will use on iOS app and Android app. We'll create an instance of this app and we'll get whatever the string is, or greeting is. Basically, could be iOS, it's going to be on Android, it's going to be Android, and then iOS is going to be the word iOS. So that's what that is. So when we have defined this simple library, the question is, how do we utilize it? And so on Android, when we build our KMM project, when you build it in Android Studio, when you go through the build process, it runs a specific number of Gradle tasks. And all those Gradle tasks are run for Android, both Android and iOS, to generate an artifact. And the artifact that it produces for Android is a jar file that you could use, that you will use. So on Android, to use this, you'll include that jar file. And then in your activity, for example, you could then basically declare a greeter object and then call greet on it. And then you'll specify it for a text view. And then you'll see the greeting on the screen, which is going to be hello Android. Because when it builds it, it knows like which actual class to use, which is going to be for the Android one. So that's what happens when in the build process, it generates a jar file for that, and you'll see this hello Android on your screen. Now so that's what it looks like on Android. So what about iOS? So iOS is a little bit different. It's going to generate an Objective-C framework, and that's a challenge because it's an Objective-C framework and not literally a pure Swift package. It's not really a pure Swift framework. It's an Objective-C one, and that brings in challenges on interoperability, how good it is, and how Swift idiomatic will be. So when you look at this, when you run the project in Gradle, when you do a Gradle build, and it's going to build an Objective-C framework, basically, and in your iOS app, that it will depend on that framework, and you can do import shared. So there's a process workflow, like whenever you're changing things in this framework, in this common shared library, KMM library, whenever you want to test out changes, you always want to do a build to regenerate the artifact so the iOS app is updated. So the iOS app, you do import shared, and then you go and basically are able to use that greeting class, and then get the greeting that you want. And then in your content view, for example, using Swift UI, you could display it. And that's going to call that method and display hello iOS is going to provide the right platform name based on the device and the platform we're in. So that's how you would implement it on iOS. So with Xcode. You could also use app code, for example. So when you look at this Objective-C framework, what's inside of it? What does your code? It gets translated and how does it look like. So when you look at the framework and what gets produced, you'll see basically, if you look at in Xcode, if you jump to the definition of these classes, you'll basically see that you could see how it's defined. You could see how how it's defined so that it's easier to use in terms of naming with Swift. So what happens in that iOS framework is that each object that you create, it gets created like there is an NS object, which is the base class. It creates a base class that inherits from NS object, and then it creates a greeting class. That the class that I have gets translated to an Objective-C class, and then a platform. It also gets translated to that. And what you'll see in these classes is that they're all prefixed with the name of my framework, basically. So when you look inside of that Objective-C framework and look at how it's defined, you'll see is that it uses this method Swift_name to make it much more friendly to use. So in all your libraries, you have this base object that is generating, which inherits object. And then you'll see is that it basically will translate in this class right here. It will translate it, you can see, to an Objective-C interface. So if you want to look at the mapping of how all of these things translate into Objective-C, you could see basically what it's going to generate by using this table that they provide with you, this native Objective-C interop. So what you see is that a class in here is an Objective-C, it's an interface, and then if you define an interface here or a suspending method, for example, like gets converted to a completion handler, you can see. And that's important to know as you're building like your API. Like if you were to make a method in here, right, and then call it init, what does that get translated to? That gets translated to do init, because on Objective-C and Swift, there's already an init method. So they have to rename it. So the problem with that is that in the end, when you're building an API, the naming becomes really weird. So you have to be mindful of that and like name your APIs something much more understandable that's common and for both platforms, Android and iOS. So you'll see in here, you know, what each of these things gets translated to in these languages. So basically, when you look at this platform object, you can see it's an interface that has read-only properties, which is, for example, this is a pointer to an NS string, the platform one. And so I'll show you an example. Well, what does this look like if you were to use like coroutines or flows? And what does that translate into, and what is the challenge with that? So we'll look at that later. So when you look at this greeter class right here, and this is what's in common, and this also gets translated to like this, which has a friendly attribute name. You can see that it provides you with. So the great thing is you could jump into that code to see how it's defined. So that's how the Objective-C framework looks like. So now let's look at a little bit more into how do you depend on, in this library, on external dependencies, platform dependencies. So suppose we had another use case where we want to generate the build of the device version, the OS version. In order to get the OS version, you need to rely on platform-specific libraries, right? For Android, maybe some build-out version class. For iOS is UI device, right? And how do you go about, relying on these platform-specific things in your library? So in Android main, when you go to its build script, what you'll see is that you could rely on whatever Android libraries that you need, and same thing with iOS. So in Android, in this source set here, I have access to the Android framework. I have access to like Android.os build version. I could get the SDK version, API level, for example, and I'm able to do that. I could also like rely on libraries that are just for Android specific libraries in here. So what about in iOS? So on iOS, you could, if I want to get the version, I could also in here rely on CocoaPods and on CocoaPods, whichever that I want. So I could also have bindings for like core data and all the UI, like UI device and foundational classes, and I could basically over here using them UI device, that current device system name, and this is in Kotlin, like so they provide you with Kotlin bindings to be able to. They provide you with Kotlin bindings for the iOS, foundational classes, the core classes, core framework classes. So I'm getting the system version name just like that. So that's a very simple example of what we looked at. How do we go about setting up a KMM project? We looked at what's inside of a shared framework. There's another thing that I want to share with you, which is in here, like not every library. There are libraries that are multi-platform, like KTOR, SQL Delight. These libraries are multi-platform libraries, and the way you depend on them is by adding their dependency to a single build script. But it becomes much more difficult when you need to depend on non-multi-platform libraries. Like suppose that I'm consuming some external SDK, and they provide one for Android and one for iOS. For in the Android main source set, I would rely on that library. In the iOS, main source set, I have to rely on either there are many ways to rely on an iOS library. The easiest way is to use this CocoaPod, but another way is to generate manually, Kotlin bindings, which is requires a little bit more work. So from my experience, I found that was a challenge basically. And sometimes when you want to include some iOS, library, you may get some weird errors. So that's one of the challenges that I found. So the next thing that I want to share with you is the CI challenges. So what we looked at so far was how to build a simple multi-platform library. And once you have built it, it's not just about building it. You need a way to consume it. To whenever someone updates it, you need to be able to generate an artifact for all of those versions, right? We all work in like either a monorepo, maybe like some format, right? We're using Git workflow, and how do we set it up in a seamless way in our setup? And that's a big question, and that's one of the big challenges that you will face. So for example, sometimes you might be using a iOS, you might be all the things might be consumed through SPM, Swift Package Manager. How do you go about setting that up? So you may be in an environment where on iOS they don't use CocoaPods. They can't consume like your framework, multi-platform framework through a CocoaPod. They want to consume it using the SPM, and that's one of the challenges. And how do you go about handling that? So you want to consume this library, this framework through SPM, and in order to do that, the good thing is that in the community there is an open source Gradle plugin that generates an XCE framework, and that could be consumed that allows you to consume it through SPM. And let me show you an example of how to set that up. So you set that up. So this is a multi-platform, the Gradle plugin, and then you would set it up in your build script, in your common build script. And then you would set up basically what Swift tool version supports is target platforms. And when you set it up, it generates a Gradle task for you. It creates a Gradle task you could execute to generate an XCE framework. And you call it create Swift package. And what that does is that it generates an XCE framework that you could host it on some repo to be consumed through SPM. So what you could do is that whenever you're building, excuse me, so you're building this Kotlin multi-platform library, right? And it's going to live somewhere. It's going to might probably be live somewhere in a separate repo. And this separate repo has the artifacts, right? It has is in their version 1.1, maybe 1.2 or 1.3. So, and in here is where the XE framework is that you would have. So in an iOS, when they go in their Xcode to specify where to get dependencies from, they could specify to get it from this repo over here, right? And the way you could do it in Xcode is that you could put in an internal repository URL, for example, you want, and then it will pick up basically the XCE framework that they could consume, and then you could specify the target for that they want to consume this library with. So that those are the two steps. It's very simple to set this up to use, and but what is much more complicated is building on top of this and then updating your workflow, creating a pipeline and CI pipeline to support this. So, which goes into something called build automation. And why is this important? It's important because when you're working on a library, you'll probably may have a getting to a one version, one by one, making updates. And at some point, you're going to do a release, right? You're going to do a release. And with that release, you generate basically a new artifact for a jar file on Android. Basically on iOS is going to be some XCE framework, and you're going to version it, right? So similarly to do with any library. But then the question becomes basically how is that going to be consumed? Where does that artifact basically go for Android and iOS apps to consume it once a release has been made? You don't want to do it manually. You want to set up an automated, easy way to do it. And you could specify how to do that either with Jenkins or CircleCI or whatever, build kite or whatever you're using. What you do is to build a pipeline to basically set this up. So whenever a commit happens, and then you are ready to release, you build a release and it sets off these sequence of steps to be able to generate this artifact. So what you would do is that when you think about if you're using Jenkins, you would set up a pipeline, and in the pipeline you could set up steps. The first step, what's going to happen? So in the first step, you run that Gradle command basically to set up and to first like testing. You're running your tests, for example, like multi-platform library has tests. If those tests pass, then build basically the artifacts. That's the second step. The third step is to store it somewhere. Store these artifacts somewhere. And where could they be stored? And there are many options that you could go by, like Google Cloud Storage, for example. You could also use a library, a service by JFrog called Artifactory. And Artifactory is like a repository. It could be only internal only that has basically these artifacts where these artifacts get uploaded to when a release occurs, right? You could set up a pipeline to do that. So then basically you have your Android and iOS apps where they're pointing to this artifactory, right? So like in your Android app, for example, you can specify to pull things from Maven Central, from JCenter. You could also specify to pull from a part of private artifactory repo and point into that internally. And then, when a release is made, is you're basically going to pull whatever newest version is from there. So setting that up is the way is really helps you to create a seamless like pipeline to improve the developer workflow basically for a KMM library. And there's articles on how to do that with CircleCI, with Jenkins, or BuildKite, or whichever CI system that you use. So those are the two steps that you could take to set up build automation for your libraries. The last thing I want to talk about are design challenges of building this. So whenever you build a multi-platform library, it's a back and forth process. You're working with an iOS developer or many of them, and then you working together on trying different things. And what will this library, like whatever you're building will probably have a way to initialize it. probably had a way to get some data from it, and it could be whatever use case you have. So you want to try out different things, and when you design your API, best approach I found is that to have the iOS developer design it in a way that's iOS idiomatic, and Kotlin developer design in a way that's Kotlin idiomatic, and come to a compromise. You won't be able to design it where it's fully iOS Swift idiomatic. There's going to be compromises, for example. And so let me give you an example of like some of the one challenge, for example, I found. One common example is that how to use flows. So flows are, what I mean by flows is that on Android there is a coroutines library similar to async await, and they provide you with be able to model a stream of data, and there you could do that in many ways. You could use flows, cold flows, or hot flows. And you could have, what if you had like you're in your API like a flow that was being exposed, and what would that look like on iOS? And there's a challenge with that. So as we saw earlier, what does it map to? So suppose you had a very simple like method in your API in this common library, common source set called get data, and you have flow, and then you have data right there. So right, it gives you a flow of data. And Android, this is simple to simple. You do flow.collect on it, right? It's Kotlin idiomatic, but then when you look at this on iOS, it becomes a problem. It becomes a problem because becomes not really easy to consume like as it is, where you have to pass in completion handlers for your error case. For example, you have to, when you think about it, a flow, when you go to collect from it, it takes in a collector. Collector is an interface. So you're going to have to create an instance of that here. And in Swift, it becomes like a lot more code to do something simple. So in order to improve how the usage on iOS, you could implement a pattern called, where you create a flow which is a custom flow. That's what I'm creating here. It wraps this origin flow, and what this has is a method that takes in a lambda. And basically, it takes in a lambda with a generic type T. And inside of here is where I'm going to consume from the flow, and I'm going to call this lambda on each, basically, every time. And then what you would do is that you would create an extension to be able to wrap this flow that you're going to use on both platforms. And what that allows us to do is that on iOS, then this would look like this: flow.wrap.watch. And it becomes much more easier to use in flows, much more easier to use the API, like you do get data wrap watch. So this is an example that you see. You also see this in the Kotlin conf app. Example. So there are libraries that provide you with reactive ways to do things. Like there's a library with reactive with the K, and that are nice that you could explore. So that's one of the challenges when you go about one. That's like an example. Another example is that suppose you make a class called basically have the method in it. You make a class like this, and over here I have a method. Imagine that this method was called init. On iOS is going to be called do init. And the naming there convention then becomes really bad. So you would have to keep in mind of the naming conventions also. So there are examples of using enums, for example. There are challenges with that, and with generics, for example. There are those are the examples that you should keep in mind. So I covered just the basics of CI challenges and gave you the basics of Kotlin Multiplatform, and I hope that was useful. So thank you for Michael for having me present, giving me this opportunity. I really appreciate it. And if you have any questions, you could DM me on my Twitter handle. you could also go to my website where I have articles on my experiences on building, on using Jetpack Compose, using coroutines, using Swift UI, and yeah, check out my website, codingwithmohit.com, and thank you.
Great. Thank you, Mohit. That's great. A lot of information here. One initial question I have is along the lines of, like, in your opinion, what kind of apps lend themselves well to doing this multi-platform approach? Are there specific kinds of apps that you would say this would be a great candidate for this approach?
So I think, well, any type of app, but there are common problems that are very useful for multi-platform. Like, I'm sure, like in an Android iOS app, we commonly do like analytics tracking to some third-party services. And like in an app, like we have defined events, right? What parameters are going to be sent for those events. Well, that's a good example. It's code and abstraction that could be shared. And that's something that's common to all kinds of apps, right? Analytics tracking, and also things such as, like, another use case is you're you may be building an A/B testing framework where for A/B testing you could be, using like Firebase config or some other optimizely library, and you have some form of abstraction around it on, looking at toggle being turned on and off. So that's something that's common. For example, that's people, migrate to build a multi-platform library. Another approach is that, you in any app you're interacting with some, you people build out an a client, right? API client that handles retries. And the great thing is that Kotlin Multiplatform has now Ktor, which knows how to use what type of, like, it could use HTTP or an SURL under the hood, but you could build an abstraction around it, like an API client for both Android and iOS. And if you have another example is, if you have an app that uses GraphQL, for example, Android and iOS app, and you could specify like a common multi-platform client, like abstraction that knows how to make queries. That's all like in this one library. And the great thing is GraphQL has Kotlin multi-platform support, GraphQL library. And so, yeah, those are different examples, like different things that we do in different apps, and that are really nice examples of using Kotlin multi-platform.
Very good. Thank you. Do we have other questions from people here on the call?
I had one around like how far or how much should be shared. I know that's been like a conversation that I've heard from other people talk about, like, should be sharing the network like you were talking about with Ktor, database, caching. Even I've heard people talking about getting sharing stuff into the presentation layer, like view models and stuff. Do you have an opinion on, where is a safe place, or maybe where are the dangerous places where we should be looking at, where we would not want to use this technology?
So, in my opinion, I would share. I think it's easy to share the network layer, the database, and any abstractions in those layers. So, but you go in the layer above that, like, I would not recommend sharing. Although you could, like, but I wouldn't recommend sharing like a view model, for example. I would recommend, like, on Android, you're using, like, probably maybe using a Hilti view model, and or maybe you might be using a wipe architecture on iOS, a presenter, and there will be differences at that layer, the UI layer, and it becomes difficult to share at that above layer. You could, like, write the whole app in Kotlin, both Android and iOS, but I wouldn't recommend that. I think that there are differences obviously in both of these platform, iOS and Android, and how we build UIs. Like there's a difference between Swift UI and I think that keeping that UI layer, the view model layer, basically, and the view layer to be distinct, basically, because how we add animations, how we go about creating that layer, the things on that layer are different, and yeah, that's my opinion. I think that at the bottom, in the view model layer, you could inject things that are shared, like for example, like maybe some metrics tracking abstraction that you have, business logic things that are good to share. um, so yeah, that's me, my example, not to go beyond, not to go to the point of sharing the UI layer, but that's just my opinion. Yeah. Anyone else have any other questions? Has anyone built a multi-platform library before or tried it out?
I haven't built one yet, but I did have another question I had written down about debugging.
Yeah.
What kinds of tools or opportunities are there for the concept of debugging?
For debugging, I believe like TouchLab that's a company that does a lot of things in the Kotlin multi-platform space. They have a tool, and for Xcode and debugging, basically, that you could utilize. Um, in Android Studio, obviously, you just when you could use the common set of tools that you have on Android Studio also. So debugging can be a challenge, but now there have been a lot of people that have trying out multi-platforms. There is a knowledge base that people have found these problems that you could check out. But debugging has been, like in my experience from my journey in using it, a one of one of the obstacles. For example, like when I went to utilize a library, a CocoaPod in the iOS, section of the code, and I had obstacles in consuming that. I got weird errors and encountered obstacles in consuming that, and there's a Square library, I forgot the name, but that really helped me to be able to consume that CocoaPod, but there were people who had similar issues that helped me a lot. Another thing to know is that multi-platform has object, freezing an object, and all that, and those are also good to know.
When it comes to things like unit tests for your inside of your Kotlin library, are there any any gotchas around those, or any places where we can expect to find trouble running those unit tests?
No, I didn't have any issues with that. There's really nice examples that they have. I was able to run them as part of the CI pipeline process of these unit tests.
So I imagine that this, if you do things more locally, I mean, I work on watches right now, and you're always worried about power consumption. And we end up doing a lot more on device. But I imagine, have you ever heard of people trying this for like, Apple versus Android watches?
No, I never heard of that. But that's interesting to try. I guess the question is, what is the common logic you would share for in that use case?
Yeah, I mean, there's lots of different things you could share, depending on what kind of app you're working on. There's a lot of
No,
doing calculations on device.
yeah.
So, because I do remember when I was at Manchester, we did use shared library, that's C++ shared library for layout of family trees.
Okay.
I don't know if they still use that.
And Mohit, another thing you mentioned early on was that there's a lot of it. The tooling, or part of this is in Objective C. Is that right? Or are there plans to move this more to Swift for those parts that are Objective C right now?
Yeah, so I think that's more of a long-term plan. So, it's not like something immediate. That was one of the pushbacks on using Kotlin Multiplatform.
And those pushbacks, were they primarily because of the enums and maybe the structs and things that are available in Swift, but
Yeah.
so available in Kotlin?
Well, say it again. Then they're not available. No, they're available in Kotlin. I mean, it's not a problem with Kotlin using it in Kotlin, but because it's not pure Swift, it becomes a problem, as you were saying, in value types and all that.
So if I'm an iOS developer and this is like something I would like to look into, to see how things work. Say for example, I'm in a company and there's a drive to try out Kotlin Multiplatform. As an iOS developer, what are some of the ways that I can best prepare myself for this? You mentioned the CI/CD and things like that. You also mentioned debugging. There may be some tools out there to help us debug. But is there anything that I should know, maybe from a tools perspective on the Android side? I mean, would you advise like an iOS developer to install Android Studio and get used to that? I'm thinking more of like team relations. This is kind of changes the paradigm a bit from just an iOS developer and just an Android developer. Now there's a little mix here. Do you have any experience with that kind of like transformation?
I do. So that's a good point, and it is a transformation because, like, suppose you have a team, right, that builds this library, they have to maintain it, and it's probably a team of iOS engineers, maybe like iOS and Android. And one of the challenges from my experience versus sharing knowledge with the iOS engineer, that's what I did, which is going through and teaching like what is Kotlin multi-platform, like working through an example. The iOS engineer did install, Android Studio, and I also installed Xcode. So, going into the other world is, it's important, because if there is an issue, that the problem with just having this not knowledge in one corner is that if there's an issue that pops up, then someone on the team, on any team, like, needs to be able to support it, right? They need to be able to support, and that's one of the costs for using this type of technology, is that you need to do some onboarding, you need to do some training on the team for the iOS engineers. And going before building the iOS library, like before building this KMM library, going through that onboarding is having, sharing the knowledge beforehand, trying different things, like is very, very beneficial to, to collaborate together on, on the library, building the library. And the other problem is that one of the challenges is that, like, if a team, you have a team of people who built the library, right, and iOS and Android engineers. So, if you don't have the one question becomes, if that team isn't there, then you don't want a feature team to be able to go into the weeds of this library, of the multi-platform library, and it becomes a problem if they don't know how to work with it. So you really have to have uh, some team, maybe an infrastructure team that understands, like both on collaborative iOS and Android, that knows how to work with, how to update a multi-platform library. And that's a challenge. So that you have to look into. The other is that if you build a multi-platform library, usually if you're in a larger company, you'll have like maybe 50 or more engineers that are going and building features. Introduce it in a way that doesn't disturb them, like doesn't disturb their workflow. It's smooth and easy to use. Like if you were to introduce it, does it affect their build time? Like you have to look into that. Does it does it affect their any like in their workflow as they're using this library? Does it affect their workflow? How easy it is? What obstacles, when you're collaborating together as a team, building this library, obviously you want to identify the risk and find a way to mitigate them. Like, and what are those risks if there were to be used in a large team, a team of 100 engineers, for example, in a big code base? And when you're trying to figure out, like, are you going to build maybe you have a monorepo with so many different Gradle modules, right? And if you were to build this library, like you have it as Gradle modules inside of this repo, how does it affect build times? How does that affect the workflow? Is it better to move it off to a different separate repo? Like exploring those teams collaboratively is going to be very, very important. So, onboarding, to answer your question in summary, onboarding is, it's the cost to you that you pay, that you have to go through, both iOS, and Android engineers and the team that's going to be responsible for maintaining this library, maintaining this multi-platform library. Anyone have any other questions?
I appreciated one of your last slides. You have your Twitter handle and website where you've got code examples, different things to review, correct?
Yes.
Yeah. Yeah, I think that's great. Yeah, I appreciate your time and answering our questions. Anybody else have any other questions before we wrap this up?
Hey, if people want to stay after and chat, welcome to do it.
Yeah, sounds good. Well, again, Mohit, thanks for joining us and sharing your knowledge and examples, and it's been a great experience to get to know this Kotlin multi-platform topic a bit more.
Yeah, thank you.
Yeah, thank you.